So before getting into this program, first we shall know what is DC motor, what's the use of it, what's the application of it. So all those things we shall know. Okay, so DC motor basically it is an hardware device which converts electrical energy in the form of direct current into mechanical energy. So basically, it usually accepts electrical energy, and that electrical energy will be converted into the mechanical energy. So through that electrical energy, so DC motor has a head. So based on the electricity supply, based on the power supply to the DC motor, the head of the motor will rotate either in clockwise or in anti-clockwise based on the program. So in case of a DC motor, the mechanical energy produced is in the form of rotational movement of the motor shaft. So as I told, in case of a DC motor, whatever the mechanical energy which is produced after supplying the desired power to the DC motor, so it have a rotational movement of the motor shaft or motor head either in clockwise direction or in anti-clockwise direction. So the direction of rotation of the shaft of the motor can be reversed by reversing the direction of direct current through the motor. So if you reverse the direction of the direct current, the motor shaft, the rotation of the motor shaft will also be reversed in the DC motor. The motor can be rotated at a certain speed by applying a fixed voltage to it. If the voltage varies, the speed of the motor varies. So if you want a varied speed in your DC motor, then voltage should be regulated or voltage should be varied upon the motor shaft rotation or motor head rotation. So the DC motor can also be interfaced to the board by connecting it to the Reliamate RM4. So it is a driver, DC motor driver, which is already available in the microcontroller kit. I will show that driver, or I will show that driver in the next coming slide. Okay. So the direction of rotation can be changed through software or from the program which you write. So port lines used for DC motor are port 0.8 and port 0.11. So as I told in the previous video, so introduction about the microcontroller kit. So in that video, I have said the ARM processor has 64 pins. So in that there are two ports, one is port 0 and another one is port 1. In port 0, we can make use of a 28 pins. In port 1, we can make use of only 16 pins. So this DC motor is the pins of the DC motor is accommodated in port 0. Okay, so what are those pins until there? So we have 8th pin in port 0, and as well as the other pin is 11th pin in port 0. Okay, so so there are two pins, basically there are two pins in DC motor. So these two pins are accommodated in port 0. So what are the pin numbers? What are the pin numbers for the DC motors? Which means that, so the pin number 8 and pin number 11. Okay, so these are the two pins, or these are the two port numbers that is connected to the DC motor. Okay, that is connected to the DC motor from the processor. So coming to the application of DC motor, so where can we use this? Where can we use this DC motor? So we can use this DC motor in cranes, lifts, air compressor, elevators, hair dryer, vacuum cleaner, fans, wheelchairs, sewing machine, and power tools, etc. So in all these are the various examples where DC motors are still being used. Okay, so if you want to control the DC motor, or if you want to rotate the DC motor, obviously there should be a microcontroller. So in all these devices like cranes, lifts, air compressor, in all these applications, there should be a microcontroller to drive the DC motor either in clockwise direction or in anti-clockwise direction. Okay, so if this application has DC motor, which means that the DC motor will be directed by the, or will be directed by the microcontroller. It should have microcontroller as well as DC motor. So this is the image of the DC motor. So there are three DC motors here. So this is the motor shaft. You can see here, this is the motor shaft. This can also be called as the motor head. Okay, so this is the motor. So here, these are the two ports. These are the two ports. Okay, this is not like positive and negative. So there are two ports in this. So these two ports will be connected to the microcontroller. Okay, so the first port, the first line is accommodated in port 08 pin, and the second line is accommodated that will be connected to the microcontroller. The pin number is the second line will be connected to the pin number port 011th pin. Okay, so this is the DC motor actually. So this is the ARM microcontroller kit we have in our lab. So in our lab we are using LPC2148. So here you can see this is the ARM processor at the center. So it is acquired a flat package, which means that it has 4 sides. Okay, so as I told, there are total 64 pins in this ARM processor. So the 16 pin, it has a 16 pins on each side. So if you multiply 16 into 4, so you will get 64 pins. In that 64 pins, 32 pins comes under port 0, another 32 pin comes under port 1. Okay, so, and here we have a DC motor interface here. So this is a Reliamate RM4 interface. So in this interface, to this interface, we need to connect the DC motor. So as I shown in the previous figure, so there are 2 lines, 2 wires. So these 2 wires should be connected to this connector. Okay, so there is a notch at the connector that is connected to the DC motor that should be connected here. Okay, so in the execution video, I will show in detail how to connect the DC motor to this interface. So this is the interface. Okay, so these are the port lines. So here port 08 pin should be activated, as well as port 011th pin should be activated. Then only the DC motor, the DC motor will works. Okay, so either it will works anti-clockwise direction, or it works in, or it will rotates in clockwise direction based on the program. So based on the instruction which is given in the program. Okay, these are the 2 pins where we need to connect the DC motor. Okay, this is the DC motor interface that is available in the microcontroller kit. So this is the LPC2148 microcontroller kit which we are using in our lab. Okay, so coming to the pins configuration. So as I told, there are 64 pins in our microcontroller, so we cannot use all the 64 pins for each and every program. Okay, whatever the pin number which is desired for the peripheral, like a DC motor or in stepper motor, so we can use only those pins. Okay, to drive the motors, we can use only those pins. Okay, as I told, there are 2 pins. There are 2 pins that are associated for the DC motor. The first pin is called as a port 08 pin, and the second pin is called as a port 011th pin. So here P stands for port, 0 stands for the port number. So we have, as I told in the previous video, there are 2 ports. One is port 0, another one is port 1. Okay, these are the 2 pins which is available in the port 0 of the microcontroller. Okay, so the pin numbers are 8th pin and 11th pin. These are the 2 pins where we can connect the DC motor to the microcontroller. So let's see the resistor configuration. So resistor configuration to activate both the pins. So in this, what happens here? So in our program, we need to set the direction. So direction should be output direction. So why we need to set the output direction to the DC motor means the DC motor will rotate based on the program dumped into the microcontroller, which means that we will be getting the output from the a microcontroller. What output? So the output is nothing but the DC motor will rotates. The shaft of the DC motor will rotates either in clockwise direction or in anti-clockwise direction. That's the output. So if we want to get the output, so then we need to do the resistor configuration to activate both the pins. So both the pins until the port 08 pin and port 011th pin. Okay, so as I told, there are in port 0 there are 32 pins starting from 0th pin to the 31st pin. So we have 32 pins. So in that the DC motor pins are 8th and 11th pin. So you need to write 0 across all the pins, but except 8th pin and 11th pin. So these 2 pins should be activated, right? So that's why you need to represent 1 across 8th pin, 1 across 11th pin, because these 2 pins are associated to the DC motor. So if you want to activate, or if you want to execute the program for the DC motor, then obviously these 2 pins should be activated. So if you want to activate these 2 pins, then you should write 1 across the number of the pin. So under the 8th pin, you should write 1. and under the 11th pin you should write 1, and in all and for all the other pins 0 should be represented. So after converting, so these are the second row is are the binary bit conversion, the binary bit representation. So obviously, so as I told earlier, all the embedded system or in the ARM processor will only accept the data in terms of hexadecimal representation only. Data should be represented hexadecimal representation. That's why this binary representation should be converted to hexadecimal representation. So these 4 bits constitute 0, and the next 4 bits constitute 0, and the next 4 bits are 1001. So 100 means 1001 means 9. So you should write, you should represent that as 9. Next we have 4 zeros, then it will be represented as 0. Then again next we have 4 0, again it will be represented as 0. Again we have another 4 zeros, it will be represented as 0. Next we have another 4 zeros, again that will be represented as 0. So again at last from pin number 28 to 31st pin, so again there are 4 zeros that will be represented as 0. So the resistor configuration to activate both the pins, both the DC motor pins is 50900. So this is the resistor configuration which we will be using this resistor configuration in our program. I will let you know how to use this resistor configuration pin in the program later. Next, so resistor configuration to activate a single pin, and again I am telling, so as I told, there are 2 pins are DC motor. You cannot activate both the pins at the same time. You cannot activate both the pins at the same time. If you activate both the pins at the same time, then motor shaft or the motor head will not rotate either in anti-clockwise direction or in clockwise direction. Okay, so we cannot activate both the pins at a time. So if you want to execute the DC motor, then only one pin should be activated. So then only the DC motor will be rotates either in clockwise or in anti-clockwise direction. Okay, so resistor configuration to active a single pin. So at a time you can activate only single pin. So port 08. So you should represent 1 across each pin. As I told, so there are 32 pins starting from 0 to 31. So you should represent 1 across each pin. Okay, so then after converting that 0001, so after by converting from binary to hexadecimal, 0001 is represented as 1. Okay, and the resistor configuration in terms of hexadecimal for port 08 pin is 50100. So this is the resistor configuration that is used to activate the single pin, which pin means port 08 pin. Okay, next let's see how to configure the resistor for resistor configuration to activate single pin. So that is a port 011th pin. So let's see how to activate this pin. So as usual, we have a 32 pins starting from 0 to 31. You should represent 1 across 11th pin. Okay, you should represent 1 across 11th pin. So then only in microcontroller the 11th pin will be activated. The 11th pin will be activated. So here you can see we have the data as 10000 in binary format. If you convert 10000 to the hexadecimal, so obviously if you convert 10000, it will forms 8. Okay, 8 is the hexadecimal representation of 10000. It will be in 8421 format. Okay, 10000 means in hexadecimal it usually represented as 8. Okay, okay, the total hexadecimal representation after converting from binary to hexadecimal, the output, the desired configuration is 50800, 50800. So this is the resistor configuration for DC motor pins. So the first one is the resistor configuration for to activate both the pins, where you need to write 1 across both the pins in pin number 8 and 11th pin. And resistor configuration to activate only a single pin, the 8th pin, you should write 1 across the 8th pin. So as it is, you have written 1. Okay, then resistor configuration to activate single pin, so that is port 011th pin. So you need to write 1 across 11th pin, and all other pins should be 0. So after that, after that, the resistor configuration in terms of hexadecimal format is 50800. So this is the resistor configuration to activate the pins of the DC motor. Next we have a program. So I will explain the program in the Keel IDE. So before that, the result is whenever you write a program, whenever you write and execute the program, the result is when connecting DC motor to the microcontroller. So there are two pins in the DC motor. If you connect to those two pins or those two pins of the DC motor to the microcontroller interface, to the DC motor interface, which is situated in the microcontroller board. So then the motor head, the shaft of the motor will first rotate in anti-clockwise and then it will rotate in clockwise direction. So I will explain in detail in the program how the motor shaft will rotate in clockwise direction as well as in anti-clockwise direction. Okay, so now I will show you the execution, how to open the how to type the program in Kiel IDE. Okay, so you can see here, so this is the Kiel Microvision 4. Okay, double click on this Kiel Microvision 4, which is available in the desktop. Wait for some time, the IDE will get open. So if you have any projects that is already there, that is already there when you open the the Kiel Microvision 4, then go to project, close project. Okay, go to project, then close project. Before that, I will create one folder and I will save the project as well as the file in this folder. Okay, I will rename it as, you can give any name for the folder. Okay, fine. So here, the next thing is we need to open the project, go to project, click on this project, click on new microvision project. Okay, click on new microvision project. After that, it will ask a way to save the program. So you have created one folder, right? So in the desktop, you need to select that folder. So I have created a folder as PROG. I will double click this and I will name the, you need to give a file name. You need to give a file name for the project. It can also be called as the project name. Okay. So here I will type DC motor. Okay. DC motor as the project name. Okay, don't give any extension. So don't give any extension while giving the project name. So just type DC motor and click on save. You can give anything, name can be anything. For example, in this program I'm giving DC motor. Okay, I click on save. After that, you will get a dialog box. So select device for target one. We need to select the target device where we are for what board we are writing the program. So we are writing the program for the microcontroller. The board name is LPC2148 microcontroller. So in the search bar, you can see the search bar here. Type LPC2148. Okay, when you type LPC2148, so you will get a configuration. So you will get a board, microcontroller board, LPC2148. Select this LPC2148 and click on OK. Then it will ask copy startup.s to project folder and add file to project. Why? Before, when you were executing the part A programs, so at that time you have clicked no option. But here, to execute all the part B programs, we need a startup.s file and you need to click on S. But whereas if you want to execute part A programs, then we don't need this startup.s and you can click on no in that case. But here, as we are executing part B programs, we need startup.s and we need to select S. Before that, what's the purpose of this startup.s? So startup.s is nothing but the library file. Whatever the ARM programming instructions are there, like IODIR, IO pin, we have a pin select, we have a IO clear, IO set, we have, so all these ARM instructions, ARM register instructions are all these ARM register instructions are stored in startup.s file. Startup.s is a header file. Okay, startup.s is a library file, not a header file. It is a library file where the header files like LPC2148.h, all those header files will be stored. Header files will be stored in this startup.s. So we need startup.s to execute all the part B programs. Next, you need to click on S. Okay, so after click on S, then go to file and select new. So now we have done the project creation. After creating the project, we need to create a file. Okay, create, go to new. Okay, now file has been created. Go to file and click on save as. Okay, so here you need to again go to desktop, go to the root folder which you have created at the desktop. So here this is the root folder. Now I need to give a file name. I need to give a file name. I will give the file name dc with an extension .c. So why you need to give an extension .c means here we are writing C program. Here we are executing C program. That's why the file extension should be .c. When you were executing the program, when you were executing the program in part A, the file name, so the file extension which you are giving is .asm or .s. So that's the extension you need to give to execute the part A program, because part A programs are all of assembly programs, whereas part B, so all the part B programs are of C programs. So that's why you need to give an extension as .c while naming the file. So here I am naming the file as dc.c. Okay, then click on save. Now file has been saved, but after saving the file, you need to link that file to your project. You need to link that file to the whatever the project you have created. So let's see how to link this dc.c file to our project DC motor. So here you can see in the left panel, so there is a project panel. So under that you have a target. So click on this plus symbol, select this source group one. Okay, so already in this source group one we have startup.s header file, startup.s library file, not a header file, it is a library file. So here we need to add another file, that is dc.c. So select this source group one. Okay, select this source group one, right click, add existing, select this add existing files to group source group one. Okay, when you click on this, so you will get dc. So you need to select this. Okay, so this is the dc.c which you have already created. Then click on add. Okay, when you click on this add, so you can see here dc.c file has been added into the project. Okay, so both the startup.s and dc.c, we need with these two files, where startup.s has it is a library file. All the library functions are stored in startup.s and dc.c. So here where we need to write where we need to write the program in dc.c. So if we want to execute DC motor in the microcontroller, we need these two files. These two files are compulsory. One is startup.s, which is directly created, which will directly linked and created by the compiler IDE tool. Then another one is dc.c, where we need to write the program in dc.c. After this, we need to do some settings. So we need to do some settings. What are those settings? And tell that. So again, click on this target one. So again, it is available under the project panel. So select this target one, right click, select options for target one. Select options for target one. Then the dialog box will get appear on the screen. So here at the top, there is an option called output. Okay, in this output, so there is one option called create hex file. Okay, you need to check this. Okay, so before it will be in unchecked mode. So after when you open output dialog box, so you need to check this. So you need to select create hex file. So what is this hex file? So hex file is nothing but it is an image file which is created after successful compilation of your program. After successful compilation without any errors, the hex file will be created. So why we need to create the hex file? The microcontroller board. So whatever the microcontroller board you have, so that LPC2148, it will accept the program only in terms of hex file. Hex file is nothing but the image file which is created after successful compilation. The microcontroller board accepts only the hex file. Okay, microcontroller board accepts the only hex file. So we need to create an hex file. You need to check on this hex file. And another is name of the executable. So you need to give a name of the executable file. So I will type dc. Okay, dc is the hex file which we are creating. After that, there is an option called linker. Okay, here you need to check use memory layout from target dialog. So you need to check this option, use memory layout from target dialog. Then you need to click on OK. Okay, so these are the settings which we need to do for each and every program, for each and every part B program. These are the common settings. Okay, these are the common settings. Then type the program in the type the program here. type the program here. So this is the program which we have, which I have typed. So fine. I will explain the program line by line. So here the first line is an header file which which we need to include an header file. So what's that header file is as include LPC2148.H. Here X stands for the version name. In our lab, we are using LPC2148 microcontroller board. This X can be anything, but in general you can type this as X. Okay. Otherwise, you can write 8 also. Instead of X, you can write 8 also. But in general, so you can write X and dot H. So it is an header file which you need to include. So where this header file is available, and it is available in the startup.s library file. It is available in the startup.s library file. Then why we need this header file? Because we are using ARM register instruction set like input output set, input output direction, and we have input output clear, input pin select, we have input output pin select, we have input output pin, then input output clear, input output set, input output direction. All these instructions are defined in LPC214x.h header file, and this header file is defined in startup.s library file. After that, I'm writing one function, so user defined function, so that is called as delay function. So why we need this delay function? Which for delay function is needed because when you execute the program, in microcontroller, or in the, or when you execute the DC motor, so first it will rotate in anti-clockwise direction, or it may rotate in any direction, but in our program, the first it will rotate in anti-clockwise direction. After that, we need some delay. Okay, so some delay will be applied, so which means that no rotations will be done at that delay point of time, at that point of time. After some delay, in that delay, so in that delay time, the motor shaft will be in idle state. Okay, it will not rotate in anti-clockwise or well as in clockwise direction. So the motor will be in idle state. After some delay, after some point of time, it will again rotates in another direction, clockwise direction. So that's why we need a delay function basically to execute on all, in most of the party programs, we need delay. So to interface hardware, so we need delay to see the output, so then only we can see the correct output. So that's why we need delay to execute all the RD programs. So let's study about the delay function. Here the return type which I am using is void, which means that while after executing the delay function, it will return nothing. Okay, so that's why the return type is void. So then delay, then I am passing one parameter or one argument to the delay function, unsigned int x. So int x is the argument which I am passing. So at the function call, you can see here I am passing 5000. So in all the delay function, at the function call, I am passing 5000. So that's the argument which I have designed. So unsigned int x. Okay, I'm defining one argument or one parameter x. The type of that is unsigned int. Okay, next coming delay is an delay is a function, right? Function is a body. Whatever the statement which comes under function, so whatever the statement which need to be executed under this function should be enclosed within a pair of flower braces. So here I am using a three statements. So what are in the first statement, I am declaring I and j. Okay, it is in the type, so it is the unsigned int data type. After that, I'm using for loop. So why I am using I means I is a control variable for I and j are control variables for the looping statements. So here I'm using two looping statements. One is for I is equal to 0, I is initialized to 0, and I is less than x. The for loop will go on iterate with x value. So whatever the x value you give in function calling, so the first for loop will go on iterate with that value. Okay, when it exceeds the x value, when it exceeds like 5001, so then it will come out of the for loop. Okay, so under this for loop we have another for loop, so that is nothing but for j is equal to 0, j is less than 1275. So by trial and error, I have given this number 1275. Okay, now to get a proper delay on the DC motor by trial and error, so I have given 1275. So we don't have any specific reason why we need to give 1275 only. By trial and error based on the hardware configuration, that's a constant number which I'm giving, that's it. Okay, 1275, and the j will go on incremented. And here I have an what this thing, what a semicolon. So semicolon is there at the end of for loop, which means that it is an infinite loop. So not an infinite loop, the semicolon is we don't have any statements, right? While executing the delay function, we don't want to execute other statements in the within that function. Okay, so that's why we don't have any other statements in the for loop. So that's why I have represent that's why I have given semicolon at the end of for loop. Instead of semicolon, we can open pair of flower braces. Okay, if you open pair of flower braces, then semicolon is not needed. Okay, instead of giving this pair of empty flower braces, that's why I'm representing one semicolon at the end of second for loop. So here you can see here it usually multiplies 1275 into int. Okay, into times. Okay, times is nothing but the value of x. Okay, int is nothing but the I is equal to 0 or I is equal to 1, or it can be anything. For each and every iterations, I and j will go on increment, right? So the j will go on increment. So that's the value of that's the value that should be multiplied with 1275 and into times. Times means 5000 times. So that's the value which I am passing in. That's the value I am passing here to the delay function. Okay, so this is the normal delay function. Hope you have understood this delay function. This delay function is there in each and every program. So in all the programs we have this delay function. So in the next program onwards, I will not be explaining this delay function because it's really easy. So why we are using 1275 means by trial and error method. So I have represented I have given the number as a constant number as 1275. So that number of times it will go on. It will that number of time the motor shaft, the delay function will be applied. Okay. After that, main function starts. So always you know that the program starts from the main function, right? So first I've explained delay function, but whenever you execute the C program, always it will start from the main function. So under the main function, the first statement is IODIR. So what is IODIR? As in the previous video, I have said IODIR. Why IODIR is used and to set the direction of a pin. Okay, IODIR instruction is used to set the direction of the pin. So as I told, if we want to activate here, what's the direction? There are two types of direction which can be set. One is input direction, another one is output direction. So as I told, so if it is in output direction, so we need to set the pin IODIR pin to IODIR instruction should be in output. Why means whatever the program you return, so that after executing that program, the output will be generated. In the output will be generated. What's the output? What's the output which is going to be generated? Which means that the output is nothing but the shaft, the motor shaft will go on rotate either in anti-clockwise or in clockwise. That's the output. So that's why we need to represent the output. So how to represent the output in IODIR instruction means or equals. So this is the representation where you need to give. You need to write here. Then hexadecimal representation, which I have already explained in the PPT. So if you want to activate both the pins, that is port 08 pin and port 11th pin, port 08 pin and port 11th pin. So the hexadecimal representation is 0x followed by 5 zeros 900. Here what it will do until setting both the pins port 08 and port 11 pin to high, making them as output pins. Okay, now just I am setting these two pins as the output pins. Still I have not done. Still I have not specify the function for these two pins. Next, I need to specify the function whether to these pins. So that will be written inside the while loop. So again, I'm representing, I'm using while loop here. So while of one. So again, while of one is nothing but we don't have any condition which is given in the while loop. So one means infinite loop. Infinite times the instruction is go on executed. Infinite times the instruction is go on executed under the while loop. Okay. So which means that infinite times the motor head will go on rotate anti-clockwise as well as in clockwise direction. So whenever, so usually the motor head will stops or the shaft will stops its rotation when when the microcontroller board is switched off, then only it will then only it will stop its rotation. When you switch on the microcontroller board, obviously it will start rotating, because we have used while loop. So that's the reason the loop will go on continue. The motor shaft or the motor head will go on rotates either in anti-clockwise or in clockwise direction. Then the direction whether to rotate in anti-clockwise or a clockwise direction will be done in through these instructions. So what are the instruction we have? IO set 0. IO set 0. So here IO dir 0. So 0, why I have 0 represented ಅಂತ ಹೇಳಿದ್ರೆ 0 represents port number. 0 represents port number. For this port number, I am defining IO dir instruction. So what is IO dir instruction? IO dir stands for input output dir, which means that to set the direction of a pin, I need to use IO dir instruction. Next, IO set is 0. This is O. After I we have O, and after set we have 0. So this is 0 and this is not O, but this is O. Okay. IO set 0. IO set 0 stands for input output set. Here, so what is this instruction? To set the pin to high state. So it will set the pin to high state. So that's why we need to use this instruction. Here 0 represents the port 0. As we are as both the pins, 8 pin and 11 pin, all both the pins are available in the port 0. So port 0, that's why you need to represent 0 after the instruction. If it is in port 1, in that case you should represent 1 here. Okay, 1, you should represent 1 after every instruction. But both the pins are in port 0 in DC motor. Both the pins are in port 0. So that's why you need to write 0. Then is equal to, so this is equal to what I am initializing, 0x followed by 5 zeros 100, which means that I am setting 8th pin. So I am setting the 8th pin. So you need to, as we have discussed the register configuration. So if you here only one pin I am setting. So if you set both the pins at a time, then the motor head will not rotate. It will be in idle state. So at a time you can set only one pin. So 5 zeros, after that 100. It means that setting pin to high state, rotating anti-clockwise. Then it will rotate anti-clockwise after delay function is applied. So delay, now here I am calling the delay function. From this statement, it will be redirected to the user defined function. So what is the user defined function which you have defined here? Delay is the user defined function. So what's the value which I am passing as the parameter? So 5000 is the value. Now x is initialized with 5000. Okay, x is initialized with 5000. Again, by trial and error, I am giving this 5000 as the value, because based upon the hardware interface which we are using. So again, this 5000 is the constant value which I am giving. So this is supplied as the parameter value or an argument value. Okay, so if you give more than 5000, then more delay will be applied. If you give less than 5000, the delay cannot be determined. The much of the delay cannot be determined. And again, this delay is in terms of microseconds. Okay, the delay is in terms of microseconds. Okay. Then after that, the next instruction is IO clear, IO CLR. 0 represents the port 0, which means that whatever the pin which is situated, whatever the pin which is there in the port 0, that will be cleared. So IO clear is used to set the pin to low state. Okay. After setting the pin to high state, it should be set to low state to rotate the motor in the opposite direction. First, it is rotating in anti-clockwise direction. After its rotation, we have some delay. Okay, after some delay, so then that pin should be cleared. So that's why IO clear instruction is used. So then what's the value which I am passing or initializing this IO clear ಅಂತ ಹೇಳಿದ್ರೆ, so 0x followed by 5 zeros 900, which means that if you have any previous data which is there in both the pins, like 8th pin as well as in 11th pin, both the data, whatever the data which is stored in 8th pin and 11th pin, so both the data will be erased, that will be cleared, which means that setting pin to low state, no rotations will be done in this instruction. After that, we have some delay function. Then to rotate the motor in other opposite direction, next we have another pin, right? So another pin, in the first case I have activated the 8th pin. So in the next case, to rotate the motor in the opposite direction, which means that in the anti-clockwise direction, in the clockwise direction, now I will set the which one, 11th pin to high. So 11th pin to high, if you want to set the 11th pin to high, then the resistor configuration is 0x followed by 50800, setting pin to high state, which will rotate in clockwise direction, 0x followed by 50800. Then we have some delay, 5000 delay will be applied. After that, again the pins will be cleared, so then only the new rotation will be start. So then on, if before starting with the rotation of the motor shaft, so the previous data should be cleared. So that will be cleared by the IO clear, IOCLR 0. 0 stands for the port number. Here all both the pins are of port 0, so that's why in all the instructions I am representing 0. IO clear 0, IO set 0, IO dir 0. So that's why I'm representing 0. So what the value I am passing, 0x followed by 50900, which means that 9 ಅಂತ ಹೇಳಿದ್ರೆ again both the pins, 8th pin as well as the 11th pin. So 1001 ಅಂತ ಹೇಳಿದ್ರೆ 9. So 9 in the hexadecimal. So that's why both the pins, whatever the data which is stored in the 8th pin as well as in the 11th pin, both will be cleared. So which means that setting pin to low state, again no rotation will be applied. After that, again delay function will be called. Again delay function will be called. Some delay will be occur in terms of microseconds. After that, we have used while of 1, which means that again these instructions, again this set of instruction will be executed. So we don't have any certain condition. So we don't have condition and it will go on executed until when you switch off the microcontroller board. So microcontrollers, when you microcontroller board switch off agila anta ಹೇಳಿದ್ರೆ, so usually the motor head or the motor shaft will go on rotates in anti-clockwise direction as well as in clockwise direction. So the first, whenever you switch on the microcontroller after connecting the DC motor to the DC motor interface in the microcontroller, so first it will rotates in anti-clockwise direction. After some delay, it will rotates in clockwise direction. Like this will be repeated unlimited times. This will be repeated unlimited times because we don't have any condition, which is nothing. We have used one while of 1, so infinite times. So these instructions will be executed infinite time until and unless the power is until and unless the power is off in the, or until and unless the microcontroller board is switched off. So hope you have understood this program. So it is very easy. Go through it. So if you have any doubts, you can WhatsApp me. So after writing the program, I will show you the execution now. Okay. So after you now you have typed this program. Okay. You need to save this. Okay. You need to save this. Then you need to compile. So rebuild. Rebuild means it will usually rebuild. What does this function do until it will compile the program. If any error is there, the error will be thrown out in this build output. Otherwise, the hex file will be created like this. So click on this rebuild button. It will take some time to compile the program. After that, compiling first dc.c will be compiled. After that, headers file will be linked from the startup.s library file. After that, the hex file will be created. After creating hex file, so you can see the output is generated fine with 0 errors. Now the program has been compiled and hex file has been created. Again, I'm telling why we need this hex file anta helidre. So the microcontroller will accept the data only in terms of hex file. So whatever the program you written, so here we are writing C program. C program is nothing but the high level language. Okay, so that program should be converted to machine level language by the compiler. So after that, converted machine level language will be in image file. So that is nothing but the hex file. So that hex file need to be dumped to the microcontroller. So let's see how to dump the hex file to the microcontroller. I will minimize this. Now hex file has been created and that will be saved in the root folder which you have created at the desktop. Okay, minimize this kill microvision. So to dump the hex file, DC motor hex file. So to dump the DC motor hex file, so we need another application called as a Flash Magic. Okay, Flash Magic is another application. So where we need this application to dump the hex file onto the microcontroller. So open this Flash Magic. Okay, double click on that Flash Magic application. Okay, when you double click on this Flash Magic application, okay, so when you double click on this Flash Magic application, so this will get open, so this window will get open. So here you need to select the device LPC2148. Again, these initializations are only one time. So whenever you want to re-execute the program, so it will be, the previous data will be saved. So again, no need to initialize or no need to select all this data. So select data LPC2148, then COM port, the port which the one wire should be connected to the microcontroller and to the CPU. So that port that is connected to the port called COM2, that should be selected. Then baud rate is 9600 and interface is none ISP. So these are the initialization things, so which you need to check whenever you execute the program. So this will be, so no need to set all these instruction, all this data again and again. So once you set once it is set in a computer, so it will be remains as it is. Okay, no changes will happen. So then X file, so how to dump I will let you know how to dump the X file onto the microcontroller. Here you need to select the hex file location. Okay, go to browse and go to root folder which you have created at the desktop. I will select desktop. So under this desktop, the program, this is the folder which I have created. Here you can see dc.x. So this is the hex file. You need to select this hex file and you need to open. So after opening, you need to click on this start button. So after when you click on this start, so you can see the progress bar at the bottom. So here I don't have microcontroller board, so that's why I cannot click on the start button. So I will it is available in the other video, so you please do check the other video. In that video I have shown you the entire execution of the DC motor application. So after processing, so the hex file, the hex file will be dumped to the microcontroller, and the DC motor will go on rotates in anti-clockwise direction as well as in clockwise direction. So this is how you need to execute the program. So
So this is LPC2148 microcontroller board. So here we have a DC motor driver here. Okay, so this is the DC motor driver. Here we need to connect the DC motor cable or the DC motor pin. So here there are two pins. So as I told, the first pin number is port 08 and the second pin number is port 011. So these are the two pin numbers. So where we need to connect the DC motor here. Okay, so before connecting the DC motor, so first we need to connect this microcontroller to the system. So this is the cable. So in this cable, the one end should be connected to the microcontroller and the other end should be connected to the back side of the CPU. Okay, so like this I will be connecting the one end to the microcontroller. Okay, so now we are done with connecting the microcontroller to the CPU. So next we need to supply the power for the microcontroller. So here we have an 5 volts DC power supply. So I will switch on this. Next we need to connect this power supply to the microcontroller. Okay. So after connecting the power controller, now we need to connect the DC motor. Okay, now microcontroller has switch on. So now we need to connect the DC motor. So this is the DC motor. Okay, so and this is the pin for the DC motor. So here you can see, so there are two pins. So the one pin is port 08, another one is port 011th pin. So these are the two pins. So here you can see a notch at the top. So here you can see a notch. So this notch should be connected like this here. So in the microcontroller board, this notch should be connected like this. Okay, so after connecting the DC motor to the microcontroller, next what we need to do is we need to dump the code. So after compiling the program, so as I told, one hex file will be created. Okay, so that hex file need to be dumped to the microcontroller. Let's see how to dump the hex file to the microcontroller. So after compiling it, just minimize the kill application, just minimize it. Then to dump the hex file to the microcontroller, we need another software, so that is called as Flash Magic. Okay, so here we have a Flash Magic. Just double click on this and click on OK. So here the Flash Magic, so this is the window which will get open after double click on the Flash Magic. So here you need to select the device, so and the COM port is the COM one. So the COM port is nothing but the cable which we have connected to the microcontroller, so to the microcontroller from the CPU. So that's it, that is COM one. Then the baud rate, so for all the programs for this COM one, so the baud rate always the baud rate should be 9600 and interface is non-ISP, and also the oscillator is 12 megahertz. So this is same for all the programs. Okay, then we need to click on this browse. We need to select the hex file now. So where our hex file is, go to desktop and click on the folder which you have created on the desktop. So after that you can see that micro.hex. So this is the hex file. We need to dump this hex file to the microcontroller. So select this hex file, then click on open. So now the file has been linked to the hex file in the location. So the location should be given here. Then after that you need to click on start button. Okay, so when you click on start, so it will take some amount of time to get dumped to the microcontroller. So after that, after finishing the microcontroller, so now you can see the output. So here this is the DC motor. So this is the head of the DC motor. So for some amount of time it is rotating clockwise, and we have some delay after that. So we have some delay after that, and after some delay, so again the head is turning anti-clockwise. So this is the output of the first program. So this is the DC motor head. So here you can see for some amount of time the head is turning clockwise, and we have some delay. After that again the head is turning anti-clockwise. So it is go on repeating because we have used while loop in our program. So it is go on repeating until we switch off the microcontroller. So this is the output of the DC motor. So the program is interface and controller DC motor. So in this program we are interfacing and controlling the DC motor, which means that we are rotating the motor head to the clockwise and also anti-clockwise. So this is the correct output of the interfacing DC motor to the microcontroller.